case. Okay. Um, so yeah, the very first one, I consider to be two thing points at two space points at one time point. That's task number one, right? Two thing points at two space points at one time point. Can I? Oh, jumping straight to the chase. Oh, you want to save a little time. You actually want to force me to be efficient, do you, John? Well, okay, I see your efficiency plea. All right, I'll get right to it. Does the whole room, if you see what John just put in the chat, do we want to jump straight to the chase and say, raise your hand, your electronic hand, if you agree with what John is saying in the chat? I mean, we could do it that way. I'm fine with that. Like he is saying, he's cutting to the chase and saying 1 and 2 and 4 are possible. 3 and 5 are impossible. So I want to take that seriously. And I'm about to take a vote. Hold on 1 second. We're about to take a vote. And I'm going to say the one thing you have to do is you have to vote one way or the other. So in a minute, I'm going to say, raise your electronic hand if you agree with what John Ford put in the chat. And then I'm going to say, raise your hand if you disagree with what he put in the chat. And you got to vote one way or the other. Okay, so what he put in the chat is that 3 and 5 are impossible, whereas presumably 1, 2, and 4 are possible. So raise your electronic hand if you agree that 3 and 5 are impossible. Going one, so 2 people are raising their hand, 3 people are raising their hand. So I got Elizabeth, I got Eric, I got Stephanie, and please stay with me here. Like, oh, okay, we got May, we got Jayla, we got Lizzie. Going once. Okay, so we got 6 people agree with John Ford that 7 people. Okay, going once. So we got Elizabeth, Eric, Stephanie, May, Jayla, Lizzie, Alea. Oh, not Alea. Wait, I don't know. Oh, yes, Alea. Okay. Those people are agreeing that 3 and 5 are impossible. All the rest are possible. So I'm going to say, put your hands down, please. Thank you, 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 thank you. Now I'm going to say, yes, and he will be running for office, right? Okay, and Alea, you could put your hand down, I think, because it's about to be confusing. Maybe I'll. Oh, cool. No, this is what I want to hear. Oh, interesting. Okay, I'm very glad. Wait, so I'm going to ask you, Alea, to lower you. Okay. Wait, I'm very glad of what Elizabeth just said, because I mean, we got to have some kind of discussion about this, and if we don't, I want to hear what Elizabeth has to say. And yes, what she's implying, by the way. And Lizzie. Okay, so what they're saying, and I always see why the hand thing are confusing. They're like, yeah, we do agree that those are impossible. But we don't agree that they're the only ones. Fair enough. And I want to hear about that. Let me just make sure, though, just to get the other side of the vote, because not everybody voted. Can you raise your hand if you disagree with, can you raise your hand if you disagree with John Ford's statement in the chat? Raise your hand if you disagree that 3 and 5 are impossible. Okay, or then I'm going to say, raise your hand if you disagree that they're the only impossible ones. Like, this is where Elizabeth and Lizzie would raise their hands. Raise your hand if you agree with Elizabeth or Lizzie, or if you in any way don't think that 3 and 5 are the only impossible ones. Please raise your hand. Like, that would be Elizabeth and Lizzie, right? Okay. Not only, that's great. Oh, and Stephanie. Okay. And I think that would also include how it's not full agreement. Wait, how it's not full agreement. Right. Right. Lizzie is right. I would think that Lizzie would raise her hand for that one. The only question I'm having, not to call anybody out, but Newell and Zhao Wei are, well, I guess I am calling you out. You guys here, you didn't vote for any, do you want to, I would like everybody, Oh, that's fair. That's fair. Okay. You go to yeah, right. You go to the bottom where there's buttons, and one of the buttons is reactions, and you hit that. That's funny. Okay, John. Oh my God, John's out of control. Or and if that's a problem, you can even. I totally appreciate Noel your honesty. So you can even just put in the chat. Do you or if you want to just try it right now. Do you see the reactions on the bottom? Oh, right. No, that would make sense. Right. Oh, and Xiaowei, thank you, Xiaowei. You saved me a moment there. Okay. The 1 and 5 is really similar. So I'm going to go back. Okay. So one thing is, I'm glad I appreciate what everybody's doing. One way or another, I think this activity always should have or will have some kind of discussion that leads to it. But I appreciate that you're saving me time and getting straight to the discussion that you guys want to have. It seems like there's some things to discuss though. So I'm going to go backwards here for a minute. First of all, I want to go to what Zhao. So, and now you can put your hands down. Like clearly, in other words, we do not have full consensus in this room. Like in all joking aside, I appreciate that John Ford tried to get us like straight to the like, duh, let's all see if we could just get group agreement on this. But apparently we don't have full agreement. There is something to discuss. And that's all the better for my money anyway. So I'm going to go backwards and let me first ask, and you can put your hands down now because now like we're discussing it. Zhao Wei, you say 1 and 5 is really similar. 1 and 5, they all of them are really similar. But to one thing, do you notice that 1 and 5 in number 1, it's 2 different objects, and number 5, it's just 1 object. I don't know if that they are very similar, but there is a difference. And for all of you, by the way, for all of you, the answers to any of these questions are going to be similar. Like there's only 2 possible answers for each one, possible or impossible. So some of these tests are going to share the same answer, but that doesn't mean they're the same question, right? Oh, okay, you get that. Okay, so that's Zhao Wei's thing. So let me back up. Let's talk about. So we don't have total agreement. So let's talk about where well, let's go through number 1. Number 1, it sounds like everybody, yes, if I'm looking through the chat, no matter whether you agree or disagree, it sounds like everybody's agreeing that number 1 is possible. I believe that everybody's agreeing with that. Is there, and stop me if I'm wrong, but I think that, and in fact, with number 1, I guess I'll again, forgive me if I'm wrong, but it sounds like everybody's saying number 1 is possible. And I'll cut straight to the chase since I'm showing video and I'll say, here's a demonstration of number 1. This, well, it looks like I'm flipping you off. Sorry. You can't even see the objects on the screen. But if the 2 objects are my 2 fingers, then here it is, right? These are 2 thing points at 2 space points at 1 time point. In other words, it does seem that task 1, I think you're all saying, and I'm agreeing, task 1 seems possible. And now again, stop me if there's any, but it doesn't seem like there's any disagreement in the room. And I agree. That's task 1. But now we get to task 2. We get to task 2. I'm going to stop my screen first. Well, we get to task 2, and task 2 is 2 thing points, 2 time points, 1 space point, right? In other words, sorry, I intentionally just, hold on. Bear with me for a second, sorry. Okay. Task 2, here we go. Task 2 is now 2 think points, 2 time points, 1 space point. Similar. Now, John says it's possible. Okay. But some people in this room, I believe, said it was impossible. Does anybody please have the, I mean, one of the people that said it's impossible, can I hear from you? Why do you say, could someone explain why it's impossible? No? Okay, you don't have to explain, but Okay, so John is saying this. All right, well, I do believe there were some people in the room that said this was impossible. And I really would like, oh, here we go, here we go. Oh, okay, wait, now we have a good argument. I mean, a good, healthy debate. So on the one end, John is saying, yeah, it's possible because you could put thing 1 somewhere, then take it out, and then put in thing 2. But Elizabeth is saying, it never says take it off. That is interesting. But John says, it says 2 different time points. I think I see the debate. I think that seems like a valid debate to me. Right. I hope everybody can see the chat. So Yahweh is saying 2 is possible. So here's the thing. I mean, John and Yahweh and others are saying, look, to do number 2, you'd have to do something different from what you did in number 1. It is definitely a different question and a different task. But what they're saying is it can be done. I do agree with Elizabeth that, I mean, I do recognize what Elizabeth's saying, that the instructions in the sheet never say specifically anything about how to do what. They don't say how to put something in or whether you could take something out. They don't tell you what to do, but they're just asking, can anything be done in order to accomplish? Let me put it one last final way. Each of these tasks is supposed to be a result, an outcome, an event. Like, could we take a snapshot of the universe and find? Well, no, yeah. I mean, I'm really not trying to be vague, but I guess what's vague is, excuse me, that in each one of these cases, we're just asking, in a way, we're asking about points of stuff, points of space, and points of time. And we're sort of asking, like, could you conceive of a snapshot? Could it be possible to have a photograph of the world, of some piece of the world in which such and such were the case? So task 1, we're all saying is possible because I could imagine a photograph of 2 things at 2 places at one time. Or I could imagine a movie of that. Could I imagine a movie of 2 things could I imagine a movie of 2 things at 1 space at 2 times? In other words, I mean, John's proposal of could I imagine, and Yahweh's proposal of now, I totally agree with Elizabeth that would be a different action from what I did to get there in task 1. But if the question here is it possible to do or not? I guess to cut to the chase, I think I do agree with Yahweh and that's interesting. Actually, that's funny, Spider-Man. Okay. That's awesome. To get to here's what I think. I do agree that it's possible. I totally still like the debate and engage in the debate. And I totally agree with what Elizabeth is saying and other people are saying, that it definitely requires something different. The demonstration for number 1 is this. The demonstration for number 2 is more like this. Put another way, demonstrate number 1 would require a photograph, a snapshot, an image, and number 2 would require a movie. Definitely true, but that's because in number 1, we're talking about 1 point in time, and number 2, we're talking about 2 points in time. So we need more than 1 point in time. I do think it can be done, though. I mean, I don't right, and I think it can be done. So it's both possible, but for different reasons, I think. I'm going to move on. What about number 3? Did you all absolutely agree that number 3 was impossible? I think you did, right? Yeah, stop me if I'm wrong, but I think you did. And in fact, since I think you did, that's another way of putting number 3 literally can't be. I mean, number 3 says have, well, here's number 3. Oh, wait. Right. Like, I think, stop me for a moment. I think you all agreed when we were voting before, that number 3 really is impossible. And it's impossible in a way that's, I think, more concrete or unambiguous than the difficulties with number 2. I think the difficulty with number 2 is that you had to do something different from number 1. And that's really true. And that really tells us something about time and space. They are similar, but they're apparently different because in order to have 2 things at 2 times at one space, you have to do something different from having 2 things at 2 spaces at one time. Again, in one case, you'd have to make a snapshot, and the other, you'd have to make a movie. But for number 3, it doesn't matter whether you make a snapshot or a movie. It doesn't matter what you do. You can't do it. You can't have 2 things in the same place at the same time. Now, okay. Thank you, May. Good, excellent. First of all, thank you for paying attention. Thank you for being engaged. Thank you for having the guts to say something different. And also, yeah, May has a good objection here. She's saying, well, wait a second. Why can't we go like this or something? Like, oh. What, right. And now here's the thing. This is where interpretation comes in. I'm not trying to be picky or whatever. I totally want to hear. I totally see what May's point is, that like you can approximately or roughly have 2 things in the same general space at the same time. Like, yeah, you can have 2 things on top of each other occupying the same general room. But this is, and that's totally fine and totally clever. But this is where the specific instruction in the sheet and the specific interpretation dwelled a little bit on the idea of the center points of each object. Like if we're identifying the whole object by the point at its center, by which I mean like the Euclidean point, the infinitesimal dot, the pixel at the center of each object, then that's where that instruction becomes important, because while I could put my calculator on top of this pack of cheese, don't ask me why I have a pack of cheese in the middle of class, but while I could put this calculator on top of this pack of cheese, what I can't do is have the center of the calculator at the same exact location, the same point in space as the center of the cheese. They both can't be in the same point of space, the same point of time. In other words, this is where it becomes really important that what we're thinking about is points of stuff, points of space, points of time. I don't know if that makes sense or not, or if May wants to follow up, but if we're interpreting throughout this whole sheet that way, if we're thinking of like pixels, then I think it's not really possible to have the center pixel of a calculator at the same location as the center pixel of a pack of cheese. I don't know if that makes sense or not, and you're welcome to follow up, but okay, that's what I'm saying for the moment. So it does seem to me that, again, if we're maintaining the same interpretation of all the rules throughout the sheet, then number 3 suddenly becomes very, very difficult in a way that number 1 and number 2 are not, I think. But again, you're welcome to keep responding or following up, May or anybody else. I don't know if it's okay. The other thing, I also want to respond one other clever thing about what May is saying. It's not just clever. One other wise thing about what May is saying is, if I put one thing on top of another, like literally on top, if I arrange it nicely enough, the truth of the matter is what I really can have, and this is May's point, I really can have the center of the calculator occupy the same like X coordinate of space and even the same Y coordinate of space, let's say, as the center of the cheese, The only thing is they wouldn't occupy the same Z coordinate, if you know what I mean. Like they could both be exactly as far away from the screen as each other. They could both be exactly as far away from like my wall as they are. So they could occupy the same space on this axis. I'm sorry, on this axis. They could occupy the same space on this axis. But if they're on top of each other, they're not occupying the same space as this axis on this axis. So in a way, what I'm also saying is like, this could become okay if we're just dealing with one dimension of space at a time. But if I'm including or incorporating all 3 dimensions of space, then I think it's impossible. And what I think is we were tacitly including all 3 dimensions of space in the first 2 instructions. So we kind of don't want to abandon ship and sort of suddenly change the rules now for number 3. So I'm saying, and again, I hope this is okay. I'm saying it seems to me that 3 is impossible in a way that number 1 and number 2 are not. That's my thing for the moment. Now, if I go on to number 4, task number 4, now we switch to just looking at one thing, like instead of 2 things, we're looking at one thing. And it's asking, can we have one thing point at one space point at 2 time points? Now, here's where there is also debate in the room. So I'm going to stop talking for a second. I feel like and maybe people have changed their answers since then, I don't know. But in the room, I do feel like this is where like John and Jiawei and some others were saying this is totally possible, but I think maybe Elizabeth and Lizzie or others were saying, no, this one's also impossible. So what do we think about this one, number 4? Yellow. Okay. So thank you, John, and thank you, Jayla, for stepping up. Awesome. So Jayla and John are both saying possible, but I think there anybody that I think there were, not trying to put anybody on the spot, but some people did say it was impossible. And I know after the last whole speech, like if I were one of you right now, I'd be like, yeah, I just said something 5 minutes ago, and then you Yaver spent like 10 minutes ripping apart what I said. Like, you think I'm going to talk again now? Okay. So we got Jayla, but does anybody want to talk about why they think this one's impossible? And I'll admit, by the way, the wording is very strange. You might never have thought about this before. Like it might have just thrown you into thinking there were other words, but it is saying one thing point, one space point, 2 time points. All right, I'm going to go out of some people definitely said it was impossible before, but okay, it's totally okay if you're changing your vote. But Jayla, can you explain possibly, or in the chat, or with your voice, could you either do a demonstration or sort of explain why you're saying it's possible, if you don't mind?
Sure.
What? Yeah. Oh, okay, great, cool. Okay, thank you. That's a yes. Yes, me. So yes, you think it's. Do you want? Oh, okay. Oh, cool. Okay. Oh, nicely said. I totally understand what you're saying. That's very helpful. All right, I keep saying I'll cut to the chase. You know, the one thing I never do is cut to the chase. I spend a lot of time saying I'm going to cut to the chase. Maybe I should just chase the cut. Yes. All right. Here. So I like the way Jayla is putting that. That's really, so she's saying, I think it's possible because it's like taking a picture of an item like a minute apart, or put another way, it's like maybe taking 2 pictures of an item a minute apart. It would stay in the same place, just a different time, like a subway train. Now that I am familiar with subway trains. We did. Oh, wait a minute. Wait, I'm going to hold off on the subway train for a second. That's super interesting, but super maybe confusing. But to stay on the Jayla thing for a minute, look. And again, there's something about the English that's very awkward, I know, but we're saying, can you have one thing point at one space point at 2 different time points? So one example on Jayla's thing would be like, if I go like this, all right? And then if I put something somewhere and remove it and then put it back there a little bit later. or true, right? I mean, that would be, and again, that does involve removing something. And the instructions never told me to remove anything, but they never said I couldn't either. They're just asking, can you do it? And to go one step further, and maybe this is John Ford's subway thing, to go one step further with JLAs, and I do agree with JLA, to be blunt, like you could totally do this. You could put something somewhere, take it away, and then put it there again later. And it is something that is at a point in space at one point. It's like here now, and it's here later, right? The truth of the matter is, if you really do follow that or believe it, there's nothing to stop me from going like this. Now, later, right? I mean, like, here's a pen that is somewhere at 1 o'clock. And here is a pen that is that same somewhere. Now it's 2 o'clock. Like, the truth is, I don't even have to remove the pen. I can have one thing point at 2 different time points at the same space point. I agree. Right. So far, I do think 2 is possible, and 1 is possible, and 4 is possible. To get to the final thing, task. So now we just switch the, oh, wait. Right. Wait. Right. It would be like, so good, May. Yeah, wait. It would be like sitting in the same exact position for 2 photos. Yeah, sure. Yes, exactly. But would position change the concept of the scenario? Would position change the concept of the scenario? Mean, like, right, as long as you didn't change position, I mean, as long as the center of you just hung out for a while, and someone was taking 2 photos of you, one sort of now and one later, you would be doing the scenario. If you moved away and never came back, then that would not do it. But if you just sat around and let someone take a picture of you, and you kept sitting around, and then they take another picture of you, that would be it. Yeah, what May is saying. I mean, I hope she agrees. I mean, yeah. And let me know if that doesn't make sense. Oh, cool. Okay. Oh, good talk. Good talk. I'm psyched. So that's task number 4. Now notice, this is like kind of the most subtle. I know this is all very weird and silly. Hopefully, and again, as always, maybe it's a little bit boring. Maybe you don't know where I'm going with this, any of you. Maybe you don't know why I'm doing this, but hopefully it's at least not stressful. Like, trust me, this is going somewhere. It's not meant to be stressful. And it's not meant to be boring, but it might be. But just notice this now. Task 4 was 1 thing point, 2 time points, 1 space point. Now we're just flipping the words. We're just trading the words. Task 5 is 1 thing point, 2 space points, 1 time point. Like, just a very minor adjustment in the English there. But now task 5, to cut to the chase, to not cut to the chase, I think you actually all did tell me at the outset of this, and with John's thing, I think you're all telling me that this one is in fact impossible. And stop me if there's any objections, but I think that's what you all said. And frankly, I agree. Now, it's 4 or 5. We've got like 15 minutes. We got to get so far what we have. Maybe a little deja vu. To be totally honest, whether for good or for bad, it's pretty much what John said. Actually, it's exactly what John said at the beginning, but a worthwhile discussion and investigation nonetheless. What we're saying so far is it looks like with things, with objects, if you're trying to arrange objects in space and time, if you're trying to have objects occupy space and time, there's various different ways you can have objects occupy space and time, but of the different combinations that we could consider, some are possible, some are impossible. The ones that are impossible is 3 and 5. It seems like what we're saying is stuff can occupy space and time, but two things cannot be in the same space at the same time. And we're saying one thing cannot be in two different spaces at one time. That's what we're saying so far. Now, you might wonder why we care, or why you might think, yeah, that's obvious. I always knew that. Why do you have to bother to tell me? Okay, I'll tell you. Okay. Here's why I'm doing all this. With the 12 minutes I've left, it's actually to get us rolling as to what is the point of physics 204? Like, why do we need a second course in physics? What are we going to do in the second course of physics? How is it different from physics 203? And if it's different, why is it still called physics? I don't know if you were wondering about any of those things, but here's the deal. All of physics, whether it's 203 or 204 or any other class, physics is the study of motion through space and time. Physics is the study of things moving through space and time. For something to be studied by physics, for something to be understood in a scientific way, it must be occupying space and time in a measurable, analyzable, predictable way. So everything we study in physics is a thing that is occupying space and time in a measurable, analyzable, predictable way. Everything in physics, whether it's physics 203 or physics 204. However, all the things that we studied in physics 203 are like the kind of things that you just played with on your desk for a half hour or fooled around with on your desk. All the things that we studied in physics 203 are material, tangible, concrete, massive, distinguishable, identifiable objects. They are particular objects that we ultimately call particles. All the things that you studied in 203 are very thingy things. Very tangible, hard, feelable, and all of those kinds of things totally cannot do task number 3 or task number 5. Like, what it means for something to be like a solid object is that it's solid. It can't share space with another object. Frankly, even liquids can't share spaces with other liquids. That's why they get displaced when you put an ice cube in or something like that. And frankly, even gases, as invisible as they seem, even gases cannot share space at the same time as other gases. That's why when you blow into a balloon, the skin of the balloon, the latex, the plastic, the rubber expands, moves out of the way, because the truth of the matter is that the balloon cannot share the space, even with the tiny, tiny particles of carbon dioxide or that you're blowing out of your mouth. Like, even gas shoves things out of the way. And every particle of gas cannot be over here while it's over there. But all of those things that cannot do task number 3 or task number 5 are a certain kind of thing. That certain kind of thing that cannot do number 3 or number 5 is called a particle. Whether it's really small or really big, like a planet, a particle Okay, a particle is an entity that cannot occupy two spaces at the same time and cannot share one space at one time with another particle. That's what a particle is. And particles are ultimately seem tangible, material, massive, distinct, identifiable precisely for those reasons. But particles are not the only things in the world that move through space and time in a measurable, analyzable, predictable fashion. This is the hook of this whole silly thing that all seems obvious, that all the tasks we did, or seems dumb. It's all an exploration of what is the nature of a particle. And a particle is not the only kind of thing that exists in the world. And it's not the only kind of thing that can be studied or it's not the only kind of thing that moves through time and space. And it's not the only kind of thing that can be studied by science. I'm saying there are many things, real things that exist in the world that move through time and that occupy time and space in a measurable, predictable, analyzable way, and yet can be in two, even less weird than that. I mean, great thought, John, but even less weird than that. I could think, right, we've got 6 minutes. I could think of a couple of things right now that are very real world, very normal, like very in your life, that actually, and very noticeable and measurable, well, getting closer. But in your regular everyday life, I'm saying there are things, and an electron actually is a tiny particle, to tell you the truth. An electron actually cannot be in the same place at the same time as another electron. In fact, many of you know that from chemistry, like from your study of orbital shells and the Pauli exclusion principle. You might remember the Pauli exclusion principle actually shows you how the electrons are arranged in orbitals and says that you can't actually have two electrons occupying the same state at the same time. But anyway, electrons are very, very, very tiny, but they are particular things. With 5 minutes left, I'm saying that, without getting soup. Well, yeah, we don't even have to go down. You don't have to go down. Oh, I see what you're saying. Right. And that's all very cool, but right, we're not even going down that psychedelic road right now. Here, since I only have like 4 minutes left, let me say to everybody here, I'm saying in the real world of everyday life, you actually experience a whole lot of things that are very unthingy. There are things, like all particles are thingy things, like they act the way your pen and your calculator act, like they can't share space, they can't be two places at once. This is what it really means to be a very material or tangible or solid or thingy object. I'm saying, though, there's a lot of very unthingy things that exist in the world in a really scientific, measurable way. And those are the things that we're here to study in Physics 204. I'll give you a quick example. We are running out of time. I'll give you a quick example. Right now, can anybody, just do me a favor, it'll seem really rude to you, maybe John will want to do this part. Can anybody, while I'm talking right now, just anybody turn on your microphone for a minute, or you turn off mute for a moment, and just make a noise while I'm talking, like interrupt me while I'm asking you to. Just somebody make a noise while I'm talking. I'm going to keep talking, and I want somebody to make any kind of noise or any kind of, just say a word, just anybody while I'm talking, just unmute for a minute and just say something while I'm talking, please. You'll get tons of class participation points. I'm trying to make, thank you. Okay, I don't even know who that was, but thank you. Now check it. Now listen, think about this. That's all oh, that was John. Yes. Okay. This is all why I just asked John to do this. Think about this for a minute. And this is not a trick. This is a very serious point, even though we only have 3 minutes to get you involved in what we're doing in the course. Oh, someone else. I'm sorry. Okay. But whoever it was, here's the deal. Most of you heard. Oh, it was you, Eric. Thank you very much. Okay. Thank you. Sorry. Here's the deal. There was one moment where at least I heard, and I hope you all heard, there was one moment when I heard my voice and I heard Eric's voice. I mean, I didn't know it was Eric's, but I heard Eric's voice. There was one moment where all of you heard. Right. Okay. So Jayla, for example, heard for one moment Eric's voice while she heard mine. Now let's think about it. I'm not trying to trick you. Think about it for a minute. That means there was a point in time. There was one point in time where the Eric sound and the Yaverbaum sound occupied one point in space in Jayla's ear. And I'm not trying to be weird or overly technical, but I'm saying, if ever you've ever heard two sounds at once, and you do all the time, that means that two sounds are occupying one point in space at one point in time. And I'm not joking, and I'm saying, and if you've ever played or listened to any music, music is impossible without that. Even just one chord means two notes are hitting your ear. And you could say, well, a particular part of my ear, yes, whatever part of your ear sounds have to hit for you to hear them. Both of them, and it could be very, very small, but both notes are hitting your ear at the same time. Otherwise, you wouldn't hear a chord from the piano, let alone that the guitar string is going, sound is going there too, and the vocals, whatever. We all the time, in a very, very real way, not in an accidental technical way, but in a crucial way, two sounds can be in one point in space at one point in time. Two lights can be, if you've ever worked in a theater, you shine a red spotlight on someone, you shine a yellow spot on someone. And you could say, and wherever the person standing, every single place, there's red light, there's orange light. The red light doesn't kick the yellow light out, right? They blend, or they do some ghostly thing, like John jokingly said 20 minutes ago, and I know I'm just about to run out of time. Here's what I'm saying. Sound, light, heat, electrical current, magnetic field. These things are very, very waves, right? All these things are very real. These are all examples, and you might want to quickly write this down. I know we're about to run out of time, so I don't want to spend time on the notes right now, but I'm saying sound moves through space and time in a measurable, analyzable, predictable way. Like sound is totally part of the scientific world of space and time. So is heat, so is electricity, so is light. So are waves in general. That's what we're here to study in Physics 204. We're here to study the motion of immaterial entities. We're here to use the same practices and principles that we developed in Physics 203, the same type of equations, laws, whatever, to study motion. But the difference is that the things that are moving in Physics 204 are eventually not going to be thingy things anymore. I'll say this one definitive time, and then we'll go today. In Physics 203, we studied the trajectories of particles, actual motions of things. In Physics 204, we study the propagation of information. Whether that information is a wave or an electric field, we're studying flow. We're studying how information flows from one place to another, i.e., we're studying how immaterial, intangible, non-particular entities move. Same rules, same practices, just different type of things. That's the point of, and yes, we will be using a lot of trig to do that. In fact, because we're studying the same type of physics, but because our entities will be more abstract, less concrete, and I don't mean to scare anybody, I'm trying to excite people, but we use the same laws to study more abstract entities, specifically like waves is a big early topic, like sound waves. And because the entities are slightly more abstract, so's the math. We're going to use a lot of trig and calculus. So that's what Physics 204 is about. And I'm just going to, and that's why we're here. And oh, cool. Thank you, Noel. That's such a nice thing to say. So that's what we're going to do. So ultimately, really, it's about oscillations, waves, and fields. That's what the class is about. But same physics, just different things, slightly elevated math. Try your best on the sheet for Monday. Okay, fair enough. Fair enough. We'll try to make it livable. But But maybe through this stuff, you'll see more watch. Look, I hated trig until I did this stuff. I don't want to keep you guys, but this is how I ended up liking math. I didn't like math before, but anyway, whatever. We'll talk about it then. But hopefully you see my point, whether it's exciting or not. Try your best on the homework for Monday. I will see you Monday. It's been great to see you all. Good discussion. Thank you for your patience, and goodbye, and goodbye. I'm gonna turn. Thank you, guys. Thank you. I'm just gonna questions. Oh, sorry. Oh, okay. I do that every
time. Professor?
Yes.
Oh, first, just a question. You tell me only the test 3 and 5 is impossible. So why is the 2 is possible?
2, I think, is possible. Is possible because you can go like this, and then like you put one object at one point in space at one point in time, and then the other object you put at same point in space but later point in time. I think that's why it's possible. Does that make sense?
So could you explain it for me again?
So we want 2 objects, we want 2 things at one point in space but 2 points in time. So since it's 2 points in time, we have time to trade. We put one there, and then later we put the other there. Oh, sorry. Later we put the other there. Is that
2 different? Just say. Oh, okay. So it's just a place one in same space and a place later in place another one in later, but it's in different time.
Right.
Oh, okay. So why the test 1 is possible?
Task 1 is possible because it's 2 point space at the same point in time. So you just go like this: 2 point space, 1 point time. It's possible.
Oh, so placed by 2 heads, but into 2 space.
Right.
Oh, okay. Thank you.
Thank you. Okay, bye. Thank you.